All right. So more generally, you can have what we'll call a theta join. And this is essentially just a join, but the condition here can be anything you want. Okay. Rather than just an equality condition. This could be greater than or less than or arbitrary functions and so on. Okay. And so this all pair similarity test that I talked about before is an example of a theta join. And we'll see a more detailed example in a second. And so just to point out that equijoin itself is a special case of theta join where theta is just the equality condition. All right, so there's some examples of theta joins just to sort of demonstrate that these come up pretty often in practice, more than you might be familiar with. And again, especially speaking to the people who have experience with databases, these are not going to be along foreign key relationships quite as often, right? Okay. So if you want to say find all hospitals within 5 miles of a school, well, this doesn't immediately seem like a relational algebra query or a SQL query, but it kind of is, right? It's just a join where the join condition is this distance function over the location of the hospital and the location of the school. Okay, and then I did a projection here to sort of project out the name of the hospital, because the English version of this seemed to suggest that we just want the name of the hospital and that's it. Okay, and so in SQL, this might look like this, where you say, look, give me all combinations of hospitals and schools, and then filter on the ones where the location of the hospital is less than 5 miles away from the location of the school. And here I'm kind of assuming that there exists some distance function that knows how to compute this. And we'll talk at the end about how new functions that are not part of the language or not part of relational algebra can be registered in the system, and that's this notion of user-defined functions. But trust me for right now that these things can exist. Okay. And in fact, they don't even have to be user-defined. There's many functions that are already available in databases for manipulating, say, for example, strings. And in fact, even for geographic information, there actually are distance functions available in most commercial databases. Okay. So you'll see this structure. The takeaway here is that I want you to still think join, right? Just because you don't see a equality condition doesn't mean there's not a join going on. It's just it's the same kind of join as everything else. And then the other takeaway is just to know the term theta join in case that comes up. Okay. Usually, when anybody's talking about a theta join, what they mean is, difficult joins, right? Arbitrary joins, the general case of joins. All right. So another example that's maybe you might sort of be able to think about coming up in practice in your own work is, well, find all the user clicks made within 5 seconds of some page load. And this is sort of much like the distance argument before, but now we can think about it in terms of time, which is just a one-dimensional. The one-dimensional distributive is easier to define. So we say find the click time minus the load time of the page, right? So c.click and p.load, and take that absolute value and see where that's less than 5. And so this might be when you're trying to find people who find what they're looking for quickly, right? This is a metric that web analytics people might use frequently, right? If people sort of stare at a page for a long time, maybe if it's an article, that might be good. It means they're reading the article. If it's a navigation page, it may be bad. It means they don't find what they're looking for quickly. Okay. You might also hear about band joins or range joins, and this is things like find me. There might be an interval of time, start time and end time in one table, and you're trying to find tuples from another table that fall within that interval. Okay, and we'll actually see an example of that. Okay, there's other joins. Another join to recognize that it exists is this notion of an outer join. And here, what you're saying is you want all the tuples from the left, R1, R2, we'll write it like this with this sort of missing leg here. You'll want all the tuples from the left side, if you've written it this way. And if the tuple on the right-hand side matches, great. You put it out and it's just like a regular join. But if there is no match, you still include the R1 tuple, and you pad out the other columns with null as needed. Okay. So any value you don't have, make it a null. All right, and so the variants here that aren't particularly important is left outer join, right outer join, So, whoops, jeez. Left outer join, right outer join, and sort of full outer join, which is a little bit hard to write because it looks like a cross product. The right outer join you really sort of never need because you can always just reorder the operations. Full outer join means that you want everything from both tuples padded out with null. And these are sort of ugly to reason about formally, but they come up pretty often in practice because, especially for users, when they're well, I say especially for users as opposed to applications. You know, if you're writing a query by hand, basically, many times people find it surprising that records in their table disappear because they joined it with another table, right? But that can happen because you've said that you only want pairs of tuples where some condition matches, and so you might have no matches and things disappear. And so outer join comes up as a useful way to match more what the SQL programmer is expecting, especially with novices. Okay. All right. And so an example of this, we have two tables here, anonymous patient and an anonymous job. We could do an outer join. Now, what columns did we join on here? Well, it doesn't specify. We sort of omitted it here, although technically we should write that, right there in the subscript of the join operator, but we didn't. But of course, you can probably figure it out. Well, so you look at the columns that they have in common, right? This has an age column, and this has a zip column, and this has an age column, and this has a zip column. And so it's actually on both of those columns, right? For every tuple in P, find me a corresponding tuple in anonymous job J. Whoops, there's an extra in there. Where age equals 54 and zip equals 98125. Okay. So if we had just done a join, then this tuple would be removed from the output because it has no corresponding tuple on this side. There is no 3398120. But because we did an outer join, we do include the tuple and we padded it with a null here. Okay. And we write this in SQL. I wish I'd included this. We write this in SQL. Let me back up a couple of steps here and I'll show you. So just like we have join here, you can actually write outer join explicitly. Outer if you wanted to. I'm not going to leave that in the slide because it'll be confusing since it's out of context. But and in fact, you can say left outer join, I guess, to match our example. Okay. Put in the slides. The database that you'll be using in the assignment is SQLite, which has some nice properties for a single user case. The entire database is stored as a single file, and you can pass it around and so on. So it's a good tool to sort of have in your toolbox, which is one of the reasons why I selected it for the assignments. But it actually has some limitations, and one of which is it can't express certain kinds of outer joins. Okay, in particular, full outer join.